Hello again, everybody. I was asked about finding symbols that would help interpret and analyze schematics. I found something. Actually, this is Nissan, but these are the most popular ones. An ignition switch, as you can see. Start, run. These are the selections that you make when you have your key in the ignition switch. Knock sensor is part of the many sensors that are in the cylinders. Solenoids are responsible for transmission, gear shifts. Capacitors, diodes, we don't see that much. Fuse link, and a fuse we see very often. Circuit breaker we see very often. A protected device, obviously. Now, we see these all the time. Relay, you have to know this in order to interpret automotive. As you can see, this is the circuit. At rest position, at default position. Meaning this is not connected to anything. When this is energized through current conducting through it, it creates a magnetic field. It pulls this in. Now this is in this position, right here. So therefore, current can now flow through the circuit that it's connected to. Same thing over here. Relay. Over here, current flows. This is pulled in. Battery. Now, again, ignition switch or any switch, whenever you connect it or you flip the switch, you're either going to connect it to this one, or to this one. See the lines? Now, this is the very important part to understand switches. At rest, this is normally open. And what I mean by normally open, it means this is the default. In order to activate this, we have to flip the switch to this. Now, where is the circuit connected in this normally open switch? You look for the line. The line is right here to this dot. That means in order to connect the circuit, we have to flip the switch this way. So in other words, it goes from normally open to normally closed to connect it. Now the switch can also be normally closed. Where is the circuit connected over here? At rest position at default, right here. That means when we want to open up the circuit or activate the switch, we flip it this way. So we are disconnecting the circuit. Very important. And of course, motor, all over automotive. You have to know this. But when it says M, that's a big hint, motor, right? Fuel pump, everything is a motor. Everything, all over. Power seats, power windows. I mean, everything. Speed sensor, one of the sensors again on the wheels for ABS. Now, variable resistors. This is a resistor with a set amount, meaning a value. One value. This is one that changes value. So it could be, this could be 1,000 ohms. This could be 1 ohm to 1,000 ohms. You can change it. See the little arrow? Means it's variable. Excuse me. Now we come to heating element. And where is the heating element present? Oxygen sensor. This heats up, allows oxygen sensor to be activated. And you see many oxygen sensors. Anyway, the bulbs, these are two filaments together to give a bulb. Sometimes you can use two bulbs here. This is one bulb. So those are the very popular ones, and they come up in every single schematic almost. Let's go to the circuit now. Now, how many times have you had a problem where you start your car? Guess what? The theft deterrent system is on. How do you activate? How do you deactivate it? First of all, we have to analyze and understand how the circuit works. We're dealing with a Maxima, but the same theory applies, except you can have the computer control it even more today. There's the basics. MT means manual transmission. So this part of schematic is manual transmission. No, we want to deal with automatic transmission. Go up here, AT, automatic transmission. That means we want to deal with this part of the schematic, not this. Now, relays, we just talked about how they work. Okay? We come here to the fuse. We know 12 volts is present. When we come over here to the other side of the fuse, current flows. When we come over here, W slash, that means with, theft warning. When we come over here, W slash O, it means without theft deterrent system. So if we have a system with it, we follow this path. This path, with. If we don't have one, we go to follow the path of without theft deterrent system. What's the difference? The difference would be either a straight connection to this point, or a relay is involved with a computer. In this case, the BCM is called, body control module. This body control module, as we said, a relay needs two things. Current to flow. In order to current to flow, we need B plus 12 volts, or it could be any other voltage, but we need a voltage on one side, and we need a ground. Is there a physical ground here? The computer gives it a ground or a pulse. That's what energizes it. So when the computer or the BCM in this gives it a ground or pulse, guess what? Current can now flow. Activate this. When you see this dotted line, that means this will be pulled in this way. This way. So now current can flow this way. Current flows this way to activate it. Then current flows this with the switch closed. Again, we come out this way. Again, same principle. What are we looking at? The relay again. Current needs to flow. Right? So we have 12 volts over here. We said we need 12 volts and we need a ground. How did we get 12 volts here? Guess what? 12 volts. 12 volts here. 12 volts, still 12 volts. We went through a switch. Is there a voltage drop through a switch? No. Therefore, we do not lose any voltage. 12 here, 12 here, 12 here. 12 comes in, 12 goes out. Why? No voltage loss. If this will be 10, this will be 10. This will be 9 volts, this will be 9 volts. No voltage drop across it. We come over here, we have 12 volts. Again, we didn't lose anything. This is just a wire. We activate this with current, and as you see, I have 0 volts here. Why do I have 0 volts over here? I just made a statement, indicated 2 things I needed to activate the coil, the control circuit, as it is called. Plus 12 volts, we have the 12 volts, and a ground. As you can see, transmission, range, sensor. There's a connection that goes here. Now, we just saw the symbol. This is why I chose this schematic, because all the symbols that we chose are in this schematic. So we know the symbols, but we have to put everything together. This is a switch. We just said there are many selections in a switch. What will put this switch in a mode where the current can flow? Where is the complete path? As we say, we need a complete path for current to flow. If you look at number 1, right? First gear, there is no connection to anything. Second gear, no connection. Drive, no connection. Neutral, yes, there is a connection. Where? To ground. Reverse, no connection. Park, yes, there's a connection to ground. So there are 2 possibilities that give us a connection to ground, to allow the current to go through to ground. Park and neutral. If you have it in park or neutral, we complete the circuit. And that's why it's there. If you are in any else but neutral or park, you cannot activate the relay. You cannot start the starter. That's how it works, if you ever wondered. Fine. We just went through this. Fine. Through this part of the circuit. Again, we just looked at the symbol. Same thing as before, except different names. What will give us current to flow from this fuse link? In accessories, there's no connection. In lock, there is no connection. In off, there is no connection. In run, no connection. Start, that's the only possibility that I have a connection. And where's the switch going to be? Right here. This is the switch. The switch will allow current to flow from the battery through this fuse link, going this way, going through here, coming out the ignition switch in the start position. Only in the start position because we need the starter. Right? Once it starts and it cranks the engine, guess what? Put it back to run with no connection to the starter. So we start, we go here, we go here. Now what happens over here? If you remember a statement that I made, I said we allow current to flow. Based on what? Based on this being in the right position. We have a complete path. Therefore, as you see, this is gang. You see the dotted line. This at rest position is now flipped to this position. Current can now flow here, here, here. Now what do you have? Another relay. We have the start and the solenoid. We have another relay over here, right? Activating the starter. So the solenoid and the starter can be activated. Now, notice one thing. I put 12 volts. I put 12 volts. I put 12 volts. I put 12 volts. How did I get 12 volts? Well, 12 volts from the battery, of course, right? 12 volts here. 12. Why is this 12 volts? Same principle as here. What's going from here to here? A switch. Does a switch have a lot of resistance? No. Very minimal amount. So therefore we do not lose of any voltage from here to here. We started with 12 volts. We're going to output 12 volts. They come down here. What about this? I said 12 volts here. I said 12 volts here. Why did I make such a statement? Again, this is just a switch. No resistance. You do not lose voltage drop if there is no resistance, or 0.2 ohms, whatever, which is minimal. Therefore, 12 volts coming in, 12 volts coming out of the switch. So we have the 12 volts needed for this relay to ground. Beautiful. What about this? This is a separate 12 volts. Look at this. Another battery over here, giving it 12 volts. This is energized. This will pull this in. See? How you know the symbols? Once you know one symbol, you know it all the time. Once you know the symbol for the switch, you know it all the time. You keep on doing this over and over again. You see the symbols, you know right away what it is. It's just a matter of repetition and just studying and applying the symbols. Therefore, what's the symbol? You see the little M? Motor. Starter. Current can now flow to activate the starter. So guess what? You just analyzed the whole circuit. So if somebody asks you, how much do I need to start the starter motor? You say 12 volts. How do I start it? Through a relay. If they ask, do you have a theft deterrent system? I say yes. How do you control the theft deterrent system? Through a relay. Through the body control module, through the computer. The computer controls it. So when people say, and nowadays there's also a computer for this, to activate this. So when people say, oh, it's just a starter, no, it could be the computer. Look at the computer. The computer has a role in it to activate the relay. Now, we said if the theft deterrent system has a problem, right, it keeps on making alarm, alarm, alarm. Obviously, I can't start the car. What do? Well, somebody said to me, just pull out the relay. No, you can't do that. If you pull out the relay, remember, we don't have this line over here. We're dealing with this line. If you pull this out, I have no 12 volts going to this. To activate this, to activate this, to activate the starter. What you can do is try to jump this, the relay, if you know the pins. That will activate 12 volts to this and finally get it started. Or you can ground this part of it. That's what you can do. If you jump from here to here, guess what? Now I have a path for current to flow. Through here, through here, through here. Activate this. Now current can flow here. Now, let's troubleshoot. Guess what? I come over here. I'm supposed to measure 12 volts. Correct? Guess what I'm measuring now? I went over here to this relay, came to this point. Uh-oh. 0 volts I measure. That's not good. That's not good, right? I cannot activate the starter. What can cause it? Immediately, your first reaction will say, well, this is not connected to this. Maybe the switch, right? That means no current is flowing. I'm not connected to the battery. Maybe the switch. Well, you know what? Not so fast. We can't say that. Why do I say that? Because maybe this is not activated. Maybe this has no magnetic field. Maybe this has no current. Remember, the rules associated with the relay. We have to activate this to pull this switch in. So maybe it's not with the switch. Maybe it has to do with this was not getting any current, or it was not energized in the first place. What will cause this not to be energized? That's the question. Okay, guess what we just said? Maybe this is in the wrong position. Maybe this is stuck in first gear, second gear, or whatever, right? So it could be this is the problem here also, right? Before we jump conclusions. So what are we going to do now? Now we're going to say, okay, I'm going to come over here. I measured 0 volts over here. I'm going to go to the other pins. Do I measure 0 volts over here? If I measure 0 volts over here, this tells me that I'm grounded. This must be working. If not, this would be 12 volts if it would be open. The whole voltage drop is across here. You remember the statement I just made before. Voltage drops. 12 volts here, 0 volts. So how much did I drop across this relay? I dropped 12 volts. That means it's working. If I measure 12 volts here and 12 volts here, that means I dropped 0 volts. It's not working. Therefore, I come back over here and I say, okay, maybe this has not been activated. Okay, but what would cause this not to activate? This. Maybe the BCM is the problem besides the fuse. Oh, wow. So the module can cause a domino effect. If the BCM is not complying the way it's supposed to, this will not work. If this doesn't work, this doesn't work. If this doesn't work, guess what? This doesn't work. If this doesn't work, this doesn't work. If this doesn't work, this doesn't work. If that doesn't work, no starter. Engaging to the flywheel, to the crankshaft. So not so fast. We have to determine which way it is. If I measure 12 volts here and 0 volts, that tells me what? That tells me that this works, the computer. Because if this wouldn't work, I would have 0 volts here, not 12 volts, right? If it wouldn't work, the fact that I get 12 volts means this works. This gave it a ground. This is energized. If this is energized, this is energized, and it gives me this. That's why I say, try to look at the schematic as best as possible. It's difficult, but that's how you diagnose. Thank you for subscribing. Please subscribe to Joe Electronic Schematics from Auto, which is one about basic electronics for students, and the other one is Automotive Electronic Schematics by Joseph, and where you see much more diagnosing. Like I said, even though it's a Nissan Maxima, Toyota, Hondas, whatever, it doesn't make a difference. The theory is the same. There might be another computer involved, but relays are always involved, and you always have to be in the start position, and you always have to be in park or neutral. So if you have a problem, you might not be in the park neutral. You might have a problem with the park neutral switch. So instead of park, put it in neutral. See if it works. Okay. Okay, thanks for watching. Thank you. Please leave comments. They're always welcome, whether they're negative or positive. It just makes me improve more the channel. I know this is the only channel on YouTube that has this. Believe me, you will not find diagnosis schematics in automotive nowhere else. So this is just a trial for me to see if it works, if it gains interest. If not, maybe I'll discontinue, go on to something else in life. But we'll see what happens then. Okay?